In Here in this part of code, I go through the infix expression character by character to convert it into a postfix form. Uh, if the character is an operand like A or B, I add it directly to the postfix string. If I see an opening parenthesis, I push it onto the stack. If it's a closing parenthesis, I pop operators from the stack and I add them to the postfix expression until I find the opening parenthesis, which I then discard. When I encounter an operator, I compare its precedence with the one on top of the stack. If it has lower or equal precedence, I pop from the stack to the postfix, then push the new operator. In this way, I build the correct postfix expression while handling operator precedence and parentheses properly. Um, in this part of code, I'm taking a postfix expression and calculating its result. For example, if we have a postfix expression, and this method will go through it and give us the final result. First, I create a stack called values, where I will store the numbers. Then I go through the postfix expression character by character. Uh, if the character is a space, I just skip it because it doesn't matter for the calculation. If it is an operand, I use the get value method to get its numeric value and push that value onto the stack. If the character is an operator, um, like plus or multiple, I pop two values from the stack. Then I call the calc method to perform the operation between A and B. After calculating, I push the result back onto the stack. At the end, the top of the stack holds the final result of the postfix expression, and that's what the method returns. So basically, in this part, I'm evaluating the postfix expression step by step and returning the final answer. Now, in here, in this part of code, I directly evaluate an infix expression. That is a standard mathematical format without converting it to postfix first. I start by creating two stack, one called ops, which stores the operators, and the other called was, which stores the values or operands. And then I loop through the expression character by character. If the character is a space, I just skip it. Uh, if it's an operand like A, B, or C, I get its numeric value using the get value method and push it onto the val stack. Uh, if it's a digit like 3 or 5, I convert it into a number and also push it onto the val stack. If I see an opening parenthesis, I push it onto the op stack. If I see a closing parenthesis, I apply the operations using the apply method until I reach the matching opening parenthesis, and then I pop that opening parenthesis. When I encounter an operator like plus or multiple, I compare its precedence with the top of the op stack. If the operator at the top has higher or equal precedence, I apply it first using the apply method. Then I push the new operator onto the stack. Mm. After finishing the loop, I apply any remaining operators in the stack. At the end, the result of the expression is at the top of was stuck, and I return it. So overall, this part calculates the value of an infix expression by carefully handling operator, precedence, and parentheses using stocks. Now we are in here. This method takes an operator from the stack and pops two values to apply the operation. It uses the calc method to calculate the result of A and B, then push that result back into the value stack. Basically, it performs a single step of the overall expression evaluation. In here, these two helper methods are used to check what type of character we are dealing with. The first method is operand, checks whether the given character is an operand. If it's a letter between A and H, it's considered a variable or operand, and the method returns true. The second method is operator, checks whether the character is an operator. If it's one of the symbols, it means it's an operator, so it also returns true. Um, these two methods help us easily determine whether a character is a value or an operator. Um, in this method, I define the precedence level of a given operator. This is important because I need to know which operation should be performed first when I evaluating an expression. Here, plus and minus have the lowest precedence, so I assign them a value of 1. And multiple and divide have higher precedence, so they get a 2. The exponent operator has the highest precedence, so I assign it a 3. For opening parentheses, I return 0. They are used to force priority in expressions but don't act like regular operators themselves. If an unknown character is passed in, the method returns -1. So basically, this function helps me determine the order in which operation should be executed. In this method, um, it returns the numeric value of a given operand character. So when I receive a character like A, B, C, I use an array to get its corresponding value. Um, there is an array called values defined as 2, 3, 4, 5, 6. I calculate the index by subtracting A from the given character. For example, if a var value equals C, then C minus A equals 2. So I return the value at index 2 in array, it's 4. So basically, this method automatically provides the numeric values for operand characters. In this method, uh, takes two numbers and operator and performs the corresponding mathematical operation between them. So I'm given a, B, and operator symbol, and I return the result of that operation. And we use the switch statement here. Um, if an unknown operator is passed in, I safely return a 0 by default. So basically, this method performs the correct operation based on the given operator and returns the result. Now I'm creating a new class, a postfix converter demo class, and test some methods in here. In here, I'm basically testing the code I wrote. First, I define an infix expression, uh, like here, uh, which is a regular mathematical expression. Then I use the convert to postfix method to convert this infix expression into a postfix form. After that, I call the evaluate postfix method to calculate the result of the postfix expression. And so at the end, I have both the postfix version and the final numeric result of the expression. In short, this part runs both the conversions and the evaluation to test that everything works correctly. Here, I am printing the results of the operation to the screen. The first line prints the original infix expression I provided, and the second line prints the prefix version of that expression, and the last line prints that final result after evaluating the postfix expression. Now in here, I am printing the results for the second expression to the screen. The first line prints the second infix expression. Um, the second line prints the postfix form of that expression. And the last line shows the calculated numeric result of a postfix expression. Um, I'm clearly showing everything to the user, the original input, the converted postfix version, and the final result.